In this video, I'm going to be talking about function transformations, and let's actually start off by looking at the quadratic function. So in the quadratic function, it has the form of x squared, and if you guys remember from algebra, the quadratic function points up, and that's because there is a positive 1 in front of the x squared function. But if you put a little negative 1 in front of it, the leading coefficient this time is -1, the function points down. So it points down and is reflected over the x-axis. But now let's take 2 and add it to the function. Let's see what happens. If we add 2 to the outside of x squared, we get that the function shifts up by 2 units because of this plus 2. But now let's see what happens if we subtract 4 to the inside. If we have x minus 4 and on the outside square it, then now our function shifted 4 units to the right. That's opposite of what we would think because inside we have a -4. So we would expect it to shift left, but it actually shifted right. And now let's take a combination of these two things that we just learned. So now this function here, this x plus 2 squared minus 6 is shifting to the left by 2 units and down by 6. So anything inside the function is shifted left or right, opposite of the sign, and anything outside shifts vertically up or down, depending on the sign. Now let's take a look at the absolute value function. The absolute value function looks like a V, and it is similar to the quadratic function in the sense that if we have the negative version of it, it reflects over the x-axis and it points down. So now let's take a look at what happens when we add something to the inside. If we add something to the inside of the absolute value, it is shifted over to the left by 3 units. So it's doing the opposite of what we would think again. And if we add something to the outside, if we subtract 3, this time our graph is being shifted down by 3 units. So it's actually doing the exact same thing. Anything inside the function shifts it horizontally left or right, opposite, and anything outside the function shifts it vertically up or down. Now let's take a look at the square root of x. The square root of x looks like a curve and it starts off at 0. So it starts off at 0 and then goes on to infinity. If we take a look at the negative square root of x, then that's also reflected over the x-axis. But something interesting happens when you add a negative to the inside. And what happens is that the function is now reflected over the y-axis. We're going to talk a little bit more about this later on. But let's keep going and see what else we can figure out about this. So let's see. If we add something to the inside, if we add 2 to the inside of the square root function, our graph shifted over 2 units to the left, which is opposite what we would think because there is a 2 being added. And if we have a 3 being subtracted to the outside, our function now shifts 3 units down, which is what we would expect. And so it generally follows the same idea. Anything inside the function moves left or right. Anything outside the function moves up and down. Now let's take a look at the cubic function. The cubic function looks like half of it is going up and the other half is going down. If we take a look at the negative cubic function, negative x cubed, that's being reflected over the x-axis as well. And if we add something to it, it is being shifted up by 3 units. And if we subtract something to the inside, it is also shifting to the right by 7 units. So a combination of these two would have the function shifting to the left by 3 units and down by 7 units. So let's generalize some of these observations. Here on the side, I have a list of general function forms that we just took a look at, like the quadratic function, cubic, absolute value, and square root functions. And what we just observed is that all the values that are being added or subtracted on the inside of the function actually shift the graph horizontally, left or right, opposite of what the sign is. That's actually because of the little negative right next to the h. Because if we input a positive number, then the inside we would have x minus h. And if we input a negative number, we would have a negative times a negative, which is a positive. We also observed that anything being added to the outside of the function would be shifted vertically up or down. We also took a look at the function of negative x squared. And remember that when we took a look at that, the function was actually reflected over the x-axis and it was pointing down. So if a or b are negative, those are the leading coefficients, then our graph is reflected over the x-axis. When we took a look at the function, the square root of negative x, we actually saw that our function was reflected over the y-axis. And why do you think that is? What is the domain of the square root of negative x? Remember that a square root cannot be negative. So we're going to take the inside, which is the square root, which is negative x, and we're going to set that greater than or equal to 0. This means that in order to solve for what x is, we're going to have to divide by -1 to both sides. If we do this, anytime we divide by a negative number, remember that our sign flips. So now our domain is all the x values that are less than 0. It's never going to touch the positive side. This is why our function was reflected over the y-axis. So this is generally how function transformations work. Anything being added to the inside of the function shifts horizontally opposite of the sign, and anything being added outside shifts vertically up or down.